Awesome. Welcome everybody to AI Horizons, the November edition. So we are excited for everyone to be back here the week before our first holiday break of the Penn State semester. So we have an exciting agenda for this month. But before we get started, I have just one quick announcement. I just posted in AI Horizons Teams space. So as mentioned last month, we are releasing a AI Horizons community survey. So that is now live. I'm going to post the link here in chat. It is also pinned to our team space. But if you could take this survey, it'll take about roughly 10-ish minutes. Send it to your colleagues. It's not just for folks in AI Horizons, but it's for all faculty and staff here at Penn State. What we are looking for are new ideas for AI Horizons, how we can really elevate this space, this community for folks here at Penn State, what we can do differently, what kind of talks you want to see coming up next year, how we can make this space work better for you. So that survey is now in Microsoft Teams. It's in chat. If you have any questions, feel free to reach out to myself. Or just post them in TeamSpace and we can chat through them there. But if you would take that survey, that would be fantastic. Okay, without further ado, I would like to introduce our speaker today, Dr. Mehrdad Mahdavi. He is an associate professor of computer science and engineering at Penn State, the director of the AI Hub at ICDS, and an associate director of the Center for Artificial Intelligence Foundations and Engineered Systems in the College of Engineering. His research is on computational and statistical foundations of machine learning algorithms. And today he's going to be talking to us about AI's dual edge, innovations, risks, and the path to co-intelligence. So without further ado, Dr. Mahdavi.
Thank you, Zach, and thanks for the opportunity. I'm really happy to be here. I'm just gonna give an overview of what is this AI technology is, how it's going to, is everything is okay?
Yep.
How it's gonna basically, it's changing the research and education, and basically what is the path ahead and how we're gonna basically embrace this technology in education and research. So the artificial intelligence basically has a long story that basically, since I think 200 years ago, we tried, the scientists and in different disciplines, tried to mimic the human intelligence. Also, there is no consensus on what intelligence means, but we have some abstraction that we can reason, we can generalize, we can automate things, this kind of thing. And basically, our ultimate goal is to create machines that they can behave like humans. And it's been an old idea, and if you go back like 75 years ago, it's mostly started by few things happened that basically led to this concept of artificial intelligence. First, basically this Turing come up with the model of computation, that basically, what does it mean? How we can formulate this computation as a model that we can study. And von Neumann basically come up with the architecture of this modern computers, all the laptops we have. At the same time, Walter Pitts and McHarren, basically they come up with the model of human neuron. They come up with the model, but they didn't have any algorithm we can train them. And Roosevelt basically come up with the algorithm, perceptron algorithm, that we can train the model of the neuron they came up. And the things basically happened around 1945, 50, and the term artificial intelligence coined by this gentleman here in a workshop at Dartmouth College in 1956. And you can see famous faces here, Shannon and others, the father of information theory. I think a bunch of mathematicians, they were bored, they get together, they coined the term, and they wanted to basically do a new type of research, and they call it artificial intelligence. And this is kind of interdisciplinary. There is a philosophical debate. Can we make machines as smart as humans? Computer science, mathematics, statistics, many, many areas. And I am here showing this relationship between these terms, like artificial intelligence is a general term that we want to make machines as smart as humans. Machine learning is just subfield. Deep learning is type of algorithm in machine learning, and generative AI, ChatGPT, Cloud, etc. We see is a specific type of deep neural networks, basically. So this is just a hierarchy, and you can see how broad the area is. But since then, a lot of algorithm has been developed. I'm just showing here the key milestones. As one thing that we have to notice that since 1950, there has been a lot of ups and downs, a lot of promises made. There are articles in New York Times like 1960 that, oh, we can make machines as smart as humans. But nothing happened. AI winter came, all the fundings being cut. Again, another technology came. But to be honest, since 2010, there's a new shift. I think it's like rebirth of this technology that makes significant contributions. I'm gonna just show why this is happening and how it works in high level, and then show how it can be leveraged in research. But just to give you a sense how far, just how much progress we made in the last couple of years, this is 1989. USPS wanted to come up with an automated system that they can dispatch mails. So they had a camera that can take image of mails, process the numbers, and they can automatically dispatch the mails, which state it's gonna go. This video is on YouTube. Such excitement 20 years ago. Just recognizing digits from image. But see what happens now. It's hard for humans to see which one is muffin, which one is dog. But if you ask ChatGPT, it can exactly describe which one is muffin, which one is dog. Or even strong reasoning capabilities. Here is the question. We have a book, 9 eggs, a laptop, a bottle, a nail. How you can put them together, make it stable. This is ChatGPT. 2 years ago, 3 years ago. It gives very stupid answer. But look at ChatGPT 4 in 2004. It's just in 2 years. It gives perfect answer, which is somehow hard for humans to come up with this. So this kind of thing that in a couple of years actually shows that how fast this technology is growing. And if we dig into the history, like ChatGPT Cloud, actually Shannon, the father of information theory, he had these models 60 years ago. His goal wasn't to create a ChatGPT, but he was trying to compress information in communication network. And he used to play the game with his wife at home. Pick a piece of text from a book and ask wife to guess the letters one by one. And this is number of attempts has been made for each letter. So basically, if you learn to predict the next word, this is exactly what ChatGPT is doing. We give a prompt, predict the next word, put it back, predict the next word. This is what Shannon and his wife, Mary, was playing at home because Shannon wanted to understand the language so he can compress it. So this is like 60 years ago, but for different purpose. But basically, Shannon was trying to learn, understand language so he can compress it. And what was his language model was his wife, basically, at home. He's trying to mimic the language that the wife knows. So why then, if these are happening like 60, 70, why now? Actually, there are 3 things happen. It's a kind of timing issue. 3 things happen last couple of decades now that make this jump and significant advance in AI. One is computation. The second is smart algorithm. Third is the data. I'm going to show why this basically get together that we have this technology now. First, thanks to internet, we generating huge amount of data. This shows how much information we generate every minute. Just mind-blowing. And no wonder why Microsoft puts data centers in ocean, Facebook puts in Alaska. To keep them cool, they save energy. And to give you a sense, this is 5 megabyte IBM hard drive. Now, our laptops, our phones, they have 256 gigabytes. Just this advancement in hardware and capacity to save data and generate data. For example, ChatGPT trained on Wikipedia on all the content we human generated in 20, 30 years. So it's just the data that we generate. Second is the smart algorithm. Nobel Prize this year in physics, which is funny in physics, went to computer science. If you're curious why, you can read this Lost in Math book. Why Nobel Prize in physics goes to computer science. But anyway, some of this algorithmic advancements, for example, transformer, which is the foundation behind this ChatGPT and other language models, so we can scale to large models, to large data. We had the ideas 20 years ago, but we couldn't scale them to Wikipedia scale or had trillions of neurons or models. These architectures and efficient optimization algorithms makes it possible that we can scale them up. And obviously computational power, GPUs, TPUs. For example, each of these models that we use at this in generative AI, they trained on thousands of GPUs. It takes 1 month to train and hundreds of millions of dollars each of them. So we didn't have this computation power 10 years ago. So I think this data, smart algorithms, and computational power get together, and we have this technology, reverse of this deep learning methods. And in terms of impact, it's gonna affect many sectors. That this article from this McKinsey Global Institute, you can see it's a $13 trillion basically by 2013 in different sectors. It's gonna basically change the shape that in most of these business areas. As you can see, it's less in the areas that we need a lot of human creativity, but in the parts that we can easily automate it, it's gonna replace or displace the jobs. So, but this is the AI, but you might hear good, bad, and ugly things about AI. I'm starting with good. I think this 50 years of protein folding problem. I give you a sequence, you wanna predict what's the three-dimensional representation of the sequence. And this is the key for drug discovery. Because when we get the drug, the shape that the sequence gets in our body determines its effectiveness. This was 50 years open problem. But Google come up with some algorithms that they can predict the 3D dimensional every sequence. And this basically got the Nobel Prize this year in chemistry. So this is really good. I mean, this can shape the way drug discovery, which is a 10 billion business, it takes 10 years for every drug to come to the market. Having this algorithm is really effective and can shape the whole drug discovery. Also, you can see that this summer, basically the Google developed an algorithm that basically competed in the math Olympiad, and it got the bronze medal, silver medal, which means it solved 5 problems out of 6. And these are really hard problems. But there's a huge gap because it took days for Google, but usually humans, they have 1.5 hours. So there's a gap how it can reason. I think it requires a lot of reasoning to solve this problem, but this was a huge progress. But also we have bad issues. You know, the check.com, a couple of years ago in our faculty meetings, we were talking how to basically keep students away from check.com. The stock went down to $8 from $120 since ChatGPT came. And it's in bankruptcy recently that they're basically gone. Or some people used to write papers and even they forgot. I'm very sorry, but I haven't access. They even forgot to take these obvious sentences from ChatGPT and they put in the papers. And in San Francisco, people do this cones in front of the cruise driver's cars and they think that, oh, it's a traffic issue. They stuck there for a whole day. It's just fun in San Francisco. You see, it's not technology is not mature. You see the simple issues. And even uglier, like a robot killed a person mistaken by a box. Or 2 weeks ago, this character.ai that you can generate basically mimicked your celebrities as an agent and you can start chatting with them. And the kid got frustrated and committed suicide. So there, as you can see, there are tons of issues here in terms of making ethical, trustworthy, responsible. But the question is this: should we now reject or embrace this technology? But to be honest, every technology comes with its own advantage and disadvantage. For example, simple email. We still get spams. Some people get screwed. They pay money. It's very good technology. And I tell you a story that happened back in days when the printing machine came. Ottoman king or Khalifa, what they call, they banned printing machine from Europe for 200 years. Why? Because religious mullahs that they used to write the Holy Quran, they said, we're gonna lose our jobs. You see, we have similar issues now. They're gonna create fake versions. They had similar concerns. They banned it for 200 years. And you can see how economic damage this caused to Ottoman and Turkey back in days. So the story is that this technology is coming. It's not gonna be perfect. It's gonna happen. We should just learn, understand, and recognize strengths, and find the limitations and find the equilibrium that we can get best out of it. I think that would be the approach that is co-intelligence that I'll discuss. But what is the very idea behind this AI? So I apologize in advance if somebody in the audience is familiar, but this is like a AI 101, just to understand how this technology works. I think this helps to understand some of the issues and curses I will discuss. So basically, I
was just adding your video for just for
so
the folks
basically,
online.
every machine learning or AI we talk, it's a data-driven problem solving. This is the problems that we don't have explicit mapping from input to output. For example, if I ask you sort these numbers, we have exact procedure to convert a list of numbers into a sorted list of numbers. It's a well-defined problem. But weather prediction, cancer detection, many areas as humans, we don't know how to solve problem. What we have is data. Then machine learning algorithm basically takes this data, extract knowledge from data or patterns, and once we have knowledge, we can use the knowledge for prediction. And this is not unique to human, I'll explain, but let me give you an example. Let's say we work for Tesla. We want to write an algorithm in Python that drives the car. We put the proximity sensors, we put cameras on top, that we get all this information. Then we can ask humans, can you write down a bunch of if then else rules for driving the car, right? If the camera shows an object, brake. We can, as a human, sit down and write. But this is tedious, and there's no single forward driving. So this is kind of dead end. It's hard for humans to write this code. How about we do this? We put cameras on the taxis that they did in Virginia. They just put cameras, proximity sensors on the cars, on the taxi drivers, paid them, tell them, we use your car to gather data, how you drive. So we have driving data. Then we give this data to an algorithm, which is called machine learning algorithm. This algorithm extracts these rules for us. So if you call this if then else rule, which is knowledge, instead of human sits down and extract this knowledge manually, now we use algorithm to automate this knowledge extraction. And this is whole AI. And we can see how efficient this could be. And this is, the history, if you look, for example, this equation, this is knowledge. But if you look where this equation came from, which is the mass energy equation formula, this is like a couple of 100 years of research by physicists to understand the relationship between mass and energy, right? They did tons of experiments, they gathered data, then Einstein came up with this form. This is knowledge. Now this equation here summarizes 100 years of research and data that we gathered. And this is not unique to humans, even animals. This spider is called smart or genius spider. So the problem that this spider is trying to solve is it builds a web And when the prey hits the web, basically it wants to learn where he needs to stand or she needs to stand. So if the prey comes next time, he can quickly go and get it. So one way is that this spider can memorize all the locations on the web that previously caught the prey. But that's a memorization. You just memorize everything. You know what a spider does? A spider goes, when a prey hits the web, makes that part of web strong. So next time a prey comes, because it's thicker, it vibrates more so he can quickly go. So basically what is this spider doing is getting the data, which part of the web the prey is hitting, transfers that data into knowledge, which is making the webs thicker. So humans write equations. This spider just makes the web thicker. This is the knowledge. And then using this knowledge, you can quickly go based on vibration finding. And this is exactly what happens in human brain. Human brain has basically billions, 84 or 5 billion neurons. Each neuron you can think of as a computation unit. It has inputs. Then the neuron does some calculation based on its inputs, and each input has some weight. Gathers the input, multiplied by weight, does some calculation, and if it's upper than some threshold, it fires and it goes to the next neuron. So basically, when we see something or smell something, this input goes, multiplied by the weight, then it fires, goes to the next neuron. So, and basically what happens during the day, we gather a lot of information. When we sleep, brain, basically there's a mechanism, it's called replay, that adjusts the strengths of these neurons or weights that we call to capture the new data that we learn on a daily basis. So this is a mathematical model that Walter and McCollum came up, that basically every neuron, if you look at mathematically, has a bunch of inputs. The image we see, the smell, the sound, they connect to the central part of the neuron with some weights. Then the central part aggregates this, multiplies every input by weight, and it's going to fire or not. That's how this is a mathematical model of neuron. And this weights here is the knowledge in human brain. When we are born, all these weights are zero. There is no knowledge in human brain. As we interact, these weights are adjusted. They go up or down. And this is how human brain, actually this is one viewpoint. Some people believe that this is not how human brain works. That's the school of symbolic AI. This is called connectionism. So there is a classical debate, but it seems that our brain is kind of this connectionism and symbolic AI together. But this is exactly the model of neuron that captures human brain. And this is the whole idea behind AI. Human brain, we learn, we get data, we adjust the weights, right? Now we have the mathematical model. We can repeat the same process. We learn from data. We show the dog image to the neural network, which is billions of neurons. It makes mistake. We say, oh, this is not dog. So it goes, adjust the weights on this neuron. And we repeat this process. We repeat this process and we learn. Basically, we mimic the human learning process. And we call them artificial neural network. And this is the whole pipeline of every machine learning algorithm. We have data. We pick a model, which could be just neurons connected to each other, similar to human brain. For example, ChatGPT has 3 trillion neurons. Just think of it. It's just 10 power 14. It's a huge number of neurons. Then we use some optimization algorithm to distill the data into the knowledge on the weights or connections in the neurons. And after we distill the knowledge from data to extract patterns, this is ready for prediction. This is ready for generating new content. But it's not hard. Just think of that everything in computers are numbers. When you look at these two images, a human can easily recognize this is human, this is dog. But if you look at really the numbers represent this too, in a computer code, they are roughly same. So it's not that easy task. Also, it's not deterministic. There are too many issues we have to solve when we follow this paradigm. So what is basically last couple of years is getting people excited is generative AI. So we have two types of AIs. One is predictive, that you give input, like the USPS example I mentioned, you take the image, you want to say which number it is. Or you get an MRI image, you want to see if the person has cancer or not. The other one is generative. Generative means that you learn the distribution. For example, distribution of language. Then you can generate new content. For example, in ChatGPT, Cloud, Gemini, you give a prompt and we generate new content. But the key foundations behind both is same. We have a neural network, we have optimization, we fit data, and we try to distill the knowledge. But the purpose is one is for prediction, one is to content. But what is this generative AI, ChatGPT? How they work? I'm going to give you just in 2 slides how this technology is developed. Let's say I give you this data set, and obviously it follows the Gaussian distribution, right? Then I ask you, can you give me 4 samples from this data? For example, this is the distribution of salary at Penn State employees, right? Can you give me more samples from distribution? One way is, okay, you go out, ask salary from more people, right? This is, you generate new data. But let's say I'm lazy, I don't want to do that. A simple trick is this. I noticed that, oh, look, this is Gaussian. How about I use simple statistic to estimate the mean and variance of this distribution? Now I have the distribution, I can generate more data, right? So this distribution is the knowledge. When I basically, mean and variance is my knowledge. Once I have this knowledge, I can generate more data. This is a very simple data generation or generative machine learning. You learn the distribution. Once you have distribution, you can generate more data. But what is the distribution of text? What's the distribution of image? Nobody knows, right? It's not simple Gaussian. The idea is this. Just delegate it to a neural network. I don't care how distribution looks like. Let me fit this data to a neural network. It will learn the distribution. For example, believe it or not, the task that this ChatGPT is trained is predict the next word. What they do, they go to Wikipedia, I love Penn State. They take all the sentences from the web, whatever they can get their hands on, Wikipedia. Let's say this sentence. They remove one of the words and ask neural network to fill in the blank. Do you agree? If you have a neural network that can fill in the blanks in the text, it kind of learns the natural language? This is whole algorithm behind ChatGPT. Take all the text from web, randomly remove some of these words, ask the model to fill in the blank. As it makes mistakes and adjusts the weights to fill in the blanks, it's basically learning the distribution of text. Now, once you have this knowledge captured by neural network, you can use it to generate new data. So when you send a prompt to the ChatGPT, it predicts the next word, then puts it back, predicts the next word, puts it back, predicts the next word. And this is, you will get whole generated text. And similar thing for image. This is, for example, diffusion model that's very successful in DALL-E and others they use. Imagine I have a process that I put a cube sugar and dissolve it in the water, but I also can reverse it. So I'm dissolving the cube sugar, but then reverse engineer and get the cube sugar. If you learn this process and then you cut this in the half, you can turn dissolved cube sugar into cube sugar. What does it mean? If I start from an image in the web, keep adding noise, then reverse engineer, reconstruct. If you have a neural network that learns this process, now it can turn, after training, if you take this part, it can turn noise into image. Because it learned the whole process. If you cut in half, you have a model that can turn random image, random numbers actually, into an image. So these are, when I say smart algorithm architecture, these are architectures, and then the point is it scalable to millions of images we have in web, data, compute? You know, these are basically makes this deep learning work. But what we can do with AI, our expectation, first, automation. AI can be used to replace human in repetitive, tedious tasks. For example, sorting fruits, in a lot of things. This is we are very good at. Now AI can do automate a lot of things. Sometimes AI can capture human expertise. For example, discovering new material. So this is, we made a lot of progress last couple of years. The third aspect is wisdom. Discover something that human haven't done it yet. This, we are not there yet. Too much work needed. But this is the ultimate goal, discovery. But automation and human expertise, we made tons of progress last couple. I also want to make clear that what we wish AI could do for us. AI is a data-driven problem solving. What does it mean? It means as humans, we come up with the problem, cancer detection, MRI imaging. We know the problem, we well defined it, we generated tons of data. Now AI is solving it. But what human really needs, discovering unknowns. Something that human has no idea. Like how polymer, how vaccine, all the things that discovered, this basically, we had no idea. Sometimes actually random process, for example, polymer or vaccine, if you read the stories, they are random. So like a student was doing an experiment at lab, put more dose of some chemistry, then they invented polymer. But AI is good at easy problem. Easy problem is that as humans, we spend a lot of time, like protein folding. 50 years of research by humans, what is DNA, what is RNA, what is folding. We have data, then AI comes and solves it. The reality is if you want to really do discovery, something that we don't know, AI is not there yet. So this is, we're working on it. Okay, so this is just high-level idea that basically how AI algorithms are developed, but how it's shaping research. If you go to ChatGPT, Cloud, Gemini, you can do tons of stuff. You can create content, you can summarize research papers. You know, they are basic stuff. But actually, I'm going to take it to a next level, which is discovery. This is one of the very good examples that Google started with developing an algorithm that beats human in Go game, which is the most complicated game in the world. Then they use similar ideas to solve this protein folding problem. Because if you can solve Go, which is very hard problem, you can use the same ideas to solve protein fold, which they use, and they got the Nobel Prize. So this basically makes us, as researchers, can we basically delegate whole research process from hypothesis generation, experiment design, validation to the AI? Can we have AI scientists, basically? And this is not something luxury. There is a necessity for this. One is this. Despite all the increase, we have a number of researchers, PhD students, the research productivity is going down. And there are articles in business reviews you can read. Generating new ideas is getting hard. The second is the research and innovation are getting very interdisciplinary. If you look at back in days, 100 years ago, most of innovators, they were mathematicians, engineers, philosophers. When you go to Wikipedia, you see how come. But now we are getting in narrow area and deeper. But to be honest, most of the, for example, Nobel Prize, more than 50% are interdisciplinary researchers. They are good at least in 2 disciplines. So why these are happening? One is the problems we're trying to solve is getting really complex. Second, information overload. Just go search for COVID-19. There are 400,000 papers. Nobody on earth can, if you have to read like 1,000 papers per day, it's impossible for human, the amount of information we generate. Third is human cognitive capacity. You know, we have limited capability on doing research, this kind of thing. Third is, as I mentioned, this knowledge is a siloed. Basically, we're getting narrow areas and deeper. Sometimes we don't know what's going on in other fields. And finally, the nature human does the stuff is very slow. In the lab, even communicating knowledge, we write papers, it goes, reviewers are lazy, it takes a couple of months. It's just labor intensive both in knowledge sharing and doing the research. So this basically creates a potential for AI that actually we can change research. So we can free humans from a lot of this labor intensive task, like reading papers, summarizing, doing some of this lab stuff that is boring for humans. So humans get freed and they can focus on bigger problems. For example, there are claims that basically this AI is a new microscope, new telescope, new accelerator. And this is happening. And there are some examples, for example, Google used AI to discover new materials. Obviously, if you take these materials into the lab, you can synthesize them because there's a gap between experiment and computational work. But this model captures 800 years of knowledge. And this is exactly the path that we have to work together, human and AI. It's not going to replace, but we can delegate a lot of this task to the AI, and we can focus. And this has been now explored in physical science, material discovery, in drug discovery, that we can use this computational models. Even this Mark Zuckerberg and wife, they have this virtual cell, Stanford, they're just putting money that we can create this virtual or twin of human cell so we can study the effect of drugs, etc. Then we can accelerate a lot of drug problems that it's time consuming. Or body on chip, that we now this technology that you can create kidney on chip, that you can put under your skin. In real time, you can observe the effect of drugs so you can tune the dose. Or digital twins that, you know, it's coming, it's everywhere. That if we can create digital twin, imagine we can answer what if questions much faster. And this is exactly science. What would have happened if I change this to this? If you have digital twin, you can quickly answer those questions. You can accelerate discovery. And there is a challenge. It's called the Nobel Turing Challenge or Turing Nobel Challenge. By 2050, we're gonna have AI scientists, AI agents, that they're gonna discover something that is worthy of Nobel Prize. And if you look at the literature, you see virtual labs. A lab of AI agents and robots that they do all the things that we used to do. They read papers, they summarize, they talk to each other, they design experiment, they use digital twins to answer what if, next step, they analyze the result, they design the next step. So I think this is very likely to happen. A lot of progress has been made. And what basically for doing this is, as you can see, we have to make this interdisciplinary research. We have to talk to each other. We need to have, at school level, for example, we need to have democratized access to the AI resources, computational and researchers. And this is basically the goal of AI Hub. I'm just using this opportunity to introduce the goal of AI Hub is basically bring all these things together so we can embrace this technology for scientific discovery. And it's very simple model. We have AI experts that they are in Sensei, Amy, CSRI, and Cafe with different focuses. in ethical aspect, for example, in industry, in engineering applications. And we have other domain experts. And the AI Hub is trying to basically bring them together so they can talk to each other, they can initiate research. And these are the centers. You can go to the AI Hub webpage. You can see that with different focuses that they work on the AI aspects. And AI Hub is basically an umbrella that's trying to synergize these efforts. Okay, so education. It's changing education, as you can see, that basically it's coming to, and TLT is doing a lot of amazing stuff in this space too. But some of the things that I think on the positive side, I mean negative side, we all know academic integrity, but on positive side, this personalized training and learning, 24-hour personalized tutoring. That this is something happening. We can adapt the curriculum. They are like a Canton and Smart Sparrow. I just put here, you can check if you're interested. There are virtual learning VR systems that, you know, this coming that we can have 24/7 education at different labs. We have this grading that we have been using, Gradescope. Now actually you can use ChatGPT API for grading. And you don't need to code. You can ask ChatGPT, how can I use your API for grading? It gives you the code. You just need to run it. Then Khan Academy creating this Khan Migo that basically it's all this issues. But one of the key aspects of this which I like is that they don't give the solutions. They try to interact with the kid to give hint, as we do in office hours. And if they can and they can adapt to the background of the kid, you know, that how, then it's very interactive and very useful technology. Packback that comes for teachers that they can get rid of a lot of this boring administration because teachers spend most of the time outside of the class. So if you can use AI to automate this, they can focus more on stuff. But one thing that I've been asked, are you worried about AI, like super intelligence, what happens? I'm worried about the next generation that if they use this technology, they become less critical thinkers. Because we learn by struggling, failing. When they see the answers from ChatGPT, they don't think. I think as educators, we have to be more careful about the soft skills. We need to redesign the homework. To be honest, there is no solution for academic integrity in short term. We just need to elevate and level up homeworks that we know they have access to calculator, they have access to ChatGPT. So I think as educators, we have to also do our job in this aspect. But some of the curses that this happening, first is accountability. I'm gonna just lay down what are the issues and do we have solution or how we should basically work with these issues. One is accountability. I mentioned character AI, the kid committed suicide. Who are we gonna blame? And you might wonder why OpenAI and other companies, they don't care about the safety. There is a simple reason, business. They don't want to be liable. If they say, oh, ChatGPT is safe, and something bad happens, they will be liable, they will be sued. So they don't want to claim anything on that. So I'm not hopeful industry will solve most of these issues. And we have to just increase awareness and do research, hopefully we solve them, but not industry. Regulating AI. You know, California was ahead of every state. This is an international issue. They failed. The problem is that one of the issues, like for example, they said, oh, every model that costs more than 100 million should this. The problem is the problem with AI is that we don't have good understanding of the science of it. If you go back to cars, airplanes, there was a luxury that the technology was advancing slowly, so we had time to develop the science. The problem with AI is that the technology is growing very fast, and the science is way behind. And I don't think without having science, we could regulate this technology. Reliability, you hear about this, like Tesla car mistaking the moon with the traffic light and stuck for a couple of hours. You know, we talk about this technology, but when you see when they fail, it's just embarrassing. But this is happening. This is not mature technology. Reliability I mentioned, and actually more interesting, the robot cut the kid's finger in playing chess. You know, you might have. These are happening. Data governance, Facebook lost billion when Apple added this feature that you don't want to be tracked. This shows how much behind the scene they're stealing our data. And there are tons of data breach happening at US every month, every day. Nobody cares. So these issues are there. Security, you know, these systems are easy to fool. I give you an example. Left-hand side is Panda. You can create well-crafted noise, add it to it, which means a bunch of numbers you add. If you see that it's Panda for human, right? But if you give to AI, it says it's human. It's that easy to fool these systems. What happens? People take MRI images, add this noise. For human eyes, it's same MRI, but behind the scene, there are numbers. So if you don't have cancer in MRI, it shows you have cancer, so you can get money from insurance. So there are too many ways you can fool the systems. And to be honest, every algorithm comes to secure AI before it's presented in the conference, somebody comes and breaks that algorithm. So it's a battle. It's really hard to take that decision. AI and job. A lot of people worried about job. I believe there will be job displacement. For example, my students, software engineers, they are worried. But the point is that, yes, ChatGPT, others can automate code generation. But in future, we will need more AI engineers. So this displacement, and we should guide the kids that they learn the right technology. But other areas that they need some sympathy, creativity, they will be less affected. Like art, nursing, this kind of thing. But everything that can be automated, they will be displaced. And this plagiarism, academic integrity, as I said, we couldn't solve check.com. No way we can solve ChatGPT. I think it's time that we rethink about education, knowing that this technology exists. Bias exists. Sometimes we, as humans, we are biased. We generate biased data. So algorithm, garbage in, garbage out, it will be biased. So awareness is the key, understanding how this technology works. Decoding AI pen, unfortunately, it's really hard to say something is generated by AI or not. Google is trying to watermark that they hide some information that you can recognize, but it's really hard. So this copyright issue, this kind of thing will be challenging in future. More interestingly, imagine a world that this AI generates more content. Think what happens. Wikipedia is created by humans. Let's say 10% was malicious, but 90% were good people trying to help society. Now AI is generating this data. New York Times has a very interesting article. They train the model on the image data. Then they use the same model to generate new images. Then they train this model. What is this game that I tell something to my in a chain? I tell something to you. It's
Telephone game.
Telephone game. That N doesn't get the right message. Similar thing happening here. AI generates data. You learn the model on the AI generated data. After a couple of repetitions, it just becomes garbage. For example, look what happens. I'm looking for a recipe for making turkey. After learning on the AI-generated data, the point is that there are a lot of information hidden that to human eyes, they look good text, they look good image, but these are numbers. So it's just the quality goes down and future AI models, so God knows what they generate. So we need to move towards quality data, data curation, this kind of thing. And other gaps that exist, that there's an interesting article that AI fails. But some progress has been made, but explainability, so that basically, if you look at generative AI, there are two aspects: content generation, factuality, verifiability. Everybody talks about the first, content generation. Nobody talks about how factual, verifiable this content is. People say, oh, I uploaded a paper on ChatGPT, it gave me a good summary. Yes, because you know the field. If you have no idea about the paper, would you trust that summary? So this is, I think, the focus should move from content generation to factuality, verifiability, etc. And finally, democratizing AI. My research personally, for example, only a couple of companies can train these models. But if you look at, there are 10 million gamers in the United States. They have GPUs. In total, they have more GPUs than OpenAI. Can we incentivize gamers that they don't mine Bitcoin and help us to learn generative AI models? That's very good, would be very good for society, because now this technology is just in hands of a couple of basically industry companies, and it's really hard. Like, we cannot do too much research on generative AI because we don't have that many GPUs. We have 4 or 6, but they learn 1,000. But what is the path ahead? Sorry, I'm almost done. So there are tons of tests that they've been developed to capture intelligence. One of them is Turing test. Basically, Turing test says that, let's say you sit in a room and you chat with two. One is human, one is computer. If you cannot tell which one is human, that means that that computer program is intelligent. This is like Turing said it like 70 years ago. But if you go to this site, generative AI can pass this Turing test. Is it intelligent? It's not. So we have tons of other tests. But I encourage you to try this website. And it's going to tell you're human or you're generative AI. It's basically you can pass the Turing test. But what is my point is that basically there are a lot of hype that, oh, we're going to artificial general intelligence. AI agents that they can do many tasks. And this is called AGI. We also are artificial narrow intelligence, that you're good at one task. I think AGI might take a couple of decades, and then if it happens, we have to think about super intelligence, that you have this AI can get smarter. It's debatable, but I think artificial narrow intelligence is in a good shape to help society. And I encourage to read this book, Taming Silicon Valley by Gary Marcus. He has a very realistic viewpoint of what's going on in AI. But I believe the path ahead is co-intelligence. And I put two books here. One is this Co-Intelligence by Ethan and Life 3. I'm just putting 4 rules here. 1, always invite AI to table. This is the technology. It's gonna mature, make progress, no matter we like it or we hate it. But I think it can be our good colleague. So it's better that we use it if we can. And teach our students. I think TLT is doing an amazing job in some aspects, that they design games. Just we need to teach kids that they learn this technology. Second, be human in the loop. All these issues I mentioned, we are not at the point that we can fully trust AI. Just think, always double check, Don't just buy whatever AI says. Treat it as like a person. Basically, it's like a collaborator, right? So the idea is that don't always trust it. Try to delegate the tasks that you're confident that they can. It's like a colleague that you recognize strengths and you identify the weaknesses. Finally, this is important. Always assume it's the worst AI model. Why? Look at this prompt here. Black and white picture of other wearing a hat. This is what we had 2 years ago generated. Has nothing to do with the prompt. This is what newer models generate. Same prompt, the difference in output. So this is really evolving technology. So it's better always assume this is the worst AI model we are working. So we should need to look for better models, be on the top, so we can use this. Anyway, but what is happening, this agentic framework? I think the mouse graphical user interface that when they came, it was a huge improvement in human-computer interaction, right, this mouse. And this is the code from the inventor of computer mouse. What is happening is this, the trend is this. Imagine this large language model is your operating system. Now you can build tons of applications on top of it, and they call it agentic front. An agent that can do your tasks, an agent that can plan your travel, agent, we can come up with these agents. So hopefully this mouse and other communication technology will go away. We will have agents, AI agents in our computers that we just ask, maybe by voice, and they go and do the job for us. I think this is Microsoft, they are investing a lot of basically on this idea of agentic and other companies. That at least for the thing that we can replicate, if we can replace humans for tedious jobs, these agents will be very beneficial. Okay, thank you so much. This was last slide. I'm open for the questions. And I apologize if it was too long.
No, that was fantastic. Thank you. So we are at time, but we do have a question in chat. I have a question, so maybe we'll just take two questions. But if you do have to run online, please, by all means, go online or leave online. Remember to take the AI Horizons community survey. So we have Mark Miller had to run, but he put in some points and questions up there. But his point 3 is his question. So when and how do you or we teach responsible application of AI versus adoption by default campaigns? I don't know if you can speak to that a little bit. But
adoption by...
I'm not sure I understand the last part of this question, but I guess when do you teach responsible AI versus just adopting AI by default is how I'm interpreting Mark's question.
So I think they should go together. As I said, unfortunately, we don't have technology for ethical, trustworthy, responsible at the moment. The only solution I think in short term is awareness, just teaching what are the limitations, ethical issues. And on the other hand, we have to teach and learn how to use this technology because there are even concerns about energy consumption. Now it's become a habit for every simple thing. We go to ChatGPT for fixing grammar, for something that we can do with search engine. I mean, it's habit, but it's not fair because it's taking a lot of energy from these models. And if you have alternative solutions, we should use search engines or other. But it's very complicated thing. I personally try not to use for everything because if Google or Bing can answer. But ethical, I think the only short term is, my opinion, I might be wrong, is the awareness because there is no solution yet. Sorry, I hope I understood the question correctly.
Yeah, we have a couple folks on there saying great presentation, so thank you for that. I concur. And I think I'll just end with my question is, I loved your presentation. I thought it was very informative. And as the AI Hub Director here at Penn State, if you could give faculty one piece of advice moving into the end of this semester, maybe starting out in 2025. Now, we've had AI or generative AI for a solid year and a half. It's here. I guess what is one piece of advice you could give to faculty around teaching with AI in their classroom with their students?
Okay. Yes, that there are attempts on, at least at Penn State on education part, we have an AI degree starting next fall. So this is very hardcore degree. But I think this is a technology. All of us should learn and use it. The point is, we don't want to become AI engineers. We want to become users of this. The solution I have in mind is called horizontal integration. What does it mean? Everybody that teaching a course, first of all, there are tons of online resources you can learn about AI. I personally, my duty, I felt that I need to teach a generative AI for everyone course. It's GenEd. I'm teaching with communication department. That the kids just learn the technology in high level. We have workshop, we have, it's when they learn, actually, they appreciate it and they can do a lot of new things. So let's just embrace it in the right way, understand ethical aspects. And the horizontal integration, if there's opportunity in your course that you can add a project or homework that they can use AI, you can reach out to me or TLT. We can help you because we're already doing this kind of. But I think horizontal integration is the right way. That for the courses that they have some component that can be done by AI, please do it because these kids need to learn this technology because when they go to job market, now every sector is using it and we don't want to send them out without knowing this technology. And we would love TLT or myself at AI Hub, we can direct you to the resources and help you.
Awesome, thank you. I love that idea of horizontal integration. And the last comment on here, another person said this is one of the best AI presentations attended so far.
Thank you.
So again, I want to say thank you
Thank
for
you so
coming to
much.
AI Horizons
Thank you
and
so much.
presenting
My
your
pleasure,
ideas.
and thanks for the opportunity.
Thank you.